This is Geometry Unit 10, Lesson 10 on Proofs Practice. We are going to use the properties of the quadrilaterals that we've talked about to prove different things about them. Okay, so the first one we have here, we have this quadrilateral WXYZ with the diagonals WY and XZ intersecting at V. WX is parallel to YZ, V is the midpoint of XZ, and WZ is perpendicular to YZ. And we want to prove this is a rectangle. Now remember, we have lots of different ways to prove this is a rectangle. If we could prove this is a quadrilateral with 4 right angles, it's a rectangle. Well, we only have one thing about a perpendicular here, so probably 4 right angles isn't a good idea. If we could prove it's a parallelogram with a right angle, though, we'd be all set. We can do the right angle from this, and then we just have to prove it's a parallelogram. So we're going to prove that it's a parallelogram with a right angle. That's what we have to prove. So we can get the right angle from this. Now, to prove this is a parallelogram, we have 5 different ways to do it. So what I'm going to do is I'm going to prove that one pair of opposite sides is parallel and congruent, because they already have that WX is parallel to YZ right there. I can prove one pair is parallel. Now, if I could also prove that these triangles are congruent and get those sides congruent, I'd be all set, because then I could say one pair of sides is congruent and parallel. And then I'll deal with the right angle. Okay, so our plan here is to prove this is a parallelogram by proving one pair of opposite sides is congruent and parallel. So to do that, we need to prove that these 2 triangles are congruent. So let's see if we can do that. So my first step, I have the quadrilateral XYZ, WXYZ. With the diagonals WY and XZ intersecting at V. And we have WX is parallel to YZ. Okay, so that's my first part of my given that I have here. Okay, so I know that one pair of sides is parallel, so that gives me that. Now, if I want to prove the triangles here, I need sides or angles. What do parallel lines give you? Well, they give you alternate interior angles. So that means that this angle right here and this angle right here are alternate interior angles that are congruent. So I can say angle WXV is congruent to angle YZV. Because if lines are parallel, alternate interior angles are congruent. So that proves that these 2 angles are congruent. Now, what do the intersecting lines, the diagonals here, give you? Well, they also give you angles. They give you vertical angles. These 2 angles right here are congruent. So that is angle WVX is congruent to angle YVZ, because intersecting lines form congruent vertical angles. Congruent vertical angles. Okay, so if I go back to my givens that I have here, I've used this one, I've used this one, I've used this one. Now I have V as the midpoint of XZ. Let me put that down. And that's given. Now what does a midpoint do? A midpoint divides a segment into 2 congruent segments. So if XZ is here and V is your midpoint, that means that ZV and XV are congruent. So let me put those down. ZV is congruent to XV. A midpoint divides a segment into 2 congruent segments. All right, so let's take a look at what we've proved. I have proved these angles are congruent, these angles are congruent, this side between them. I've proved the triangle is congruent by angle side angle. So I'm going to put that down. Triangle WVX is congruent to triangle YVZ by angle side angle. Now the reason that I wanted angle side angle is I wanted to prove that WX and YZ are congruent because they'd be opposite sides of the parallelogram. Okay, so WX is congruent to YZ by CPCTC. So I have just proved that these two sides are now congruent. They were already parallel. WX and YZ are already parallel. So I have one pair of sides congruent and parallel. So I have just proved that WXYZ is a parallelogram. Because if a quadrilateral has one pair of sides congruent and parallel, it is a parallelogram. Okay, so I've now proved that WXYZ is a parallelogram. Now, I still have that WZ and YZ are perpendicular, which I haven't used yet. So I want to use that. That's given. And what is that going to give me? Well, WZ and YZ gives me angle Z is a right angle. So I'm going to put that down. Angle Z is a right angle. Because perpendicular lines form right angles. Okay, so I have proved this is a parallelogram with a right angle, so what have I proved? I have proved that this is a rectangle. WXYZ is a rectangle because a parallelogram with a right angle is a rectangle. And there we go. So notice on this, I had to prove the parallelogram, then prove that I had a right angle before I could say it's a rectangle. So that's using the properties of parallelograms and rectangles to prove them. All right, now let's use the properties of a rhombus. We have a rhombus RSTV, where we have lines VTX and STW, RS is perpendicular to SX, and RV is perpendicular to VW. We want to prove that TX is congruent to TW. All right, so TX is here, TW is there. So most likely to prove those, I'm probably going to have to prove the triangles that contain them. So I want to prove these triangles here. I want to prove that VWT and XXT are congruent. So let's see if we can do that. Now, what properties of a rhombus do we know? Well, we are given a rhombus. Well, do we have any sides or angles that we need from that rhombus to prove those triangles? Well, let's see. This side right here and this side are part of these two triangles. What do we know about the sides of a rhombus? Well, we know they're congruent. All sides of a rhombus are congruent. So that means that VT is congruent to ST because all sides of a rhombus are congruent. Okay, now what else do we have? We have VTX and STW, those two sides. VTX and STW is given. Those are two lines and they have T in common. So what does that tell me about those two lines? Well, they intersect at T, forming vertical angles. Those two angles right there are congruent. So that means that angle VTW is congruent to angle STX because intersecting lines form congruent vertical angles. So those angles are congruent. Okay, so I've used this given, and the rhombus, and then we have RS is perpendicular to SX, and RV is perpendicular to VW. All right, so RS being perpendicular to SX. Well, RS and SX would give me right angles. this right angle right here, and then RV and VW would give me this right angle right here that are congruent. Okay? So RS is perpendicular to SX, and RV is perpendicular to VW. And that's given. And that gave me angle RVW is congruent to angle RSX because perpendicular lines form congruent right angles. Congruent right angles. Okay, now, do we need this entire angle to prove these triangles? No, I only need this little piece right here, so somehow I've got to prove, get rid of this piece here and this piece here. Well, where are those angles compared to each other? Aren't they opposite angles of a rhombus? And what do we know about the opposite angles of a rhombus? This angle here and this angle here. What do we know about them? They're congruent. So if we get those congruent, couldn't we subtract it and end up what we want? Yeah, so let's do that. So we want to get those opposite angles congruent. So it's going to be angle RVT and RST are congruent. Opposite angles of a rhombus are congruent. And then we can subtract it. So if we take RVW, that we just proved was congruent, subtract out this angle, we're left with TVW. And if we take RSX and subtract RST, RSX and RST, we're left with TSX. And that's by subtraction on numbers 6 and 7. So by subtraction, I have just proved that this angle is congruent to that angle. All right, so are the triangles now congruent? Yes, they are. I've used all my givens. There we go. So the triangles are now congruent. So VTW and STX are now congruent. And that is by, we proved it by angle side angle. And therefore, is TW now congruent to TX? Yes, it is, by CPCTC. So we can use the properties of our quadrilaterals to do proofs. You just have to know which ones to use when. And there we go. So we have proved, using the fact that we had a rhombus, to prove that those two segments are congruent. A lot of times you will have to prove triangles, and then you have to use the properties of a rhombus, a square, a rectangle, whatever, in order to prove the pieces that you need.